Hello. In this video, I intend to discuss the language of functions and how to interpret functions based off of a graph. So we're going to look at specifically the skills related to using a graph, but also how to work in the language of functions, how to write your responses to demonstrate your understanding and support your thinking. So, the first thing you should do whenever you're studying a function in context is read what information has been given to you about it, because that's going to help you understand the purpose of the whole graph and everything. So, it says the function models the number of accidents per 50 million miles driven as a function of the driver's age. That's a lot to unpack, but if you look at the graph, the age is on the x-axis, which is why I define the driver's age as x. So this is telling us how old is a driver, and the y-axis says number of accidents, but it would be confusing or weird to say that 40-year-old drivers have, and read over on the graph, about 200 accidents. Like, what does 200 accidents mean? Does that mean if I'm 46, that when I drive down the highway I can expect to have 190 accidents? Not really, because what you have here is an accident rate. It says per 50 million miles driven. So in general, if 46-year-olds all the 46-year-olds happen to be driving, and you accumulate 50 million miles worth of driving amongst a population of 46-year-olds, you would expect to have about 190 accidents. So all the things you'll notice that I've talked about so far, I haven't done any writing, and I haven't even read the questions yet. The first thing you need to do before doing any of this work is read the given information and see if you can interpret what the graph is trying to tell you. So, to make that more clear, we can see the first question. The first question is asking us to evaluate f of 20. So that's function notation, but we have to know what f of 20 means within the context of this particular function. So the first thing I do is I write out f of 20, what it is, and I try to identify what the x value is supposed to be representing. Notice this is f of x, now it's f of 20. X has been replaced with 20, so what I know is we're looking at 20-year-old drivers. To find out what the value of f of 20 is, all I have to do is consult the graph. I find the 20-year-old driver right there, I follow it up to the graph, and then I follow it over to the y-axis. It's not very easy to read, it's not very clear, but you can estimate based on the numbers you can that this is approximately 430. Anywhere around 430 is going to be fine. If you said 425, if you said 435, that's fine. That's why we use the squeakles, the approximate equal sign, to say that I'm just estimating off the graph. Now we have to interpret what this means. So this is the function response, the function language, the math language for how to answer the question. Now we have to actually say what this means. And so the first thing is 430 is a useless number unless it has a label behind it. So 430 accidents per 50 million miles now clarifies what the 430 stands for. But this is a complete sentence, and we have to translate the whole sentence into our native language so we can demonstrate that we understand what the function notation is saying. This says for every 50 million miles driven by 20-year-olds, all 20-year-olds, we should expect about 430 accidents. So 20-year-old drivers don't seem to be that safe. I wonder why that would be. No possible theories here at all. Anyway, we go to part B. Part B says, solve f of x equals 300. I mentioned this in class, but we hope we understand. I'm not asking you to divide both sides by f or do anything to the equation. I'm asking you to find the value of x that makes this a true statement. So I'm wanting to know what ages are going to produce an accident rate of 300 accidents per 50 million miles driven. So what I do is I first write down the equation I'm solving, and then I identify what information was given to me. It says the y value is 300, which represents an accident rate. So I go to the graph where y equals 300, and I follow it over. Here's a mistake that students often make. They will find the first solution here, which is the first age, and they would answer the question and then move on to the next question. Notice how the accident rates sink until a certain age, and then they increase again after that age, which means there's two different ages that should expect the same kind of accident rate. People that are younger and people that are older. So again, judging from the numbers I see on the number line, I can interpolate and estimate the value of x in each of these cases at 28 years and 62 years old. So here's how I answer the question using function notation. Notice I don't just say 28 and 62, I say years, because that represents the age of drivers, not just some random number 28 or 62. Now for the interpretation, 28-year-old drivers and 62-year-old drivers both have the same accident rate at about 300 accidents per 50 million miles driven. So I suppose if you had all the 28-year-olds and 62-year-olds driving for 100 million miles, then you could expect 600 accidents. So stay off the sidewalks. All right, now for part C, it says for what value of x does the graph reach its lowest point? So I can obviously see what lowest point is. It's right here, and it's asking what value of x there is. So that value of x appears to be around 45 years old. I got that because this is 40, 60. That means this is going to be 50 in between. So we're halfway between 40 and 50, 45-year-old drivers. And here's the accident rate that's just below 200. So I'm going to estimate that to be 190. So I already read ahead, and it's asking also for the minimum value of y. So again, first thing I do is find the numbers, the data from the graph, and you'll notice that I also labeled that point on the graph. I want to go back a second because I forgot to mention. These solutions that were answers to both questions A and B are clearly labeled on my graph. If you're looking at your homework and you didn't have a graph that was labeled in this way with the x and y axes labeled clearly, accurately drawn, and then labeled so that they line up correctly, then your work is incomplete and you should go back and fix that. Same thing here. I demonstrate on the graph where I found my values, and then I write in my math notation what I just found. I found the minimum point at f of 45 approximately equal to 90. And then I have to interpret its significance. I don't just say 45-year-old drivers have an accident rate of 190. That's just restating what I already proved I know. So I rephrase this in a way that's significant about minimum. What's significant about the minimum point? And in this case, it represents the safest drivers. So when I ask about a minimum of a function, in this context in particular, it's something that's beneficial. It's like, who are the best drivers? If you're an insurance company, you're going to give the best insurance rates to your 45-year-old drivers because you're sure they're not going to get in as many accidents as those wild 20-year-olds. Let's not even talk about the 16-year-olds. Anyway, we move on. We've got the last bit about domain and range, and one of your assignments was to do the research on what domain and range mean, and so I still expect that you've done that. The words are on the page, and so I will just demonstrate how to answer these domain and range questions in the most complete and demonstrably understandable way. So the first thing is it said describe and state. So describing is telling me what is the domain representing in context. Stating is what is the actual set of numbers that the domain is holding. So first of all, the description is what does the domain represent? It represents the possible ages of drivers. How old are the drivers that could work in this particular function? Then to answer the question, I can just shadow the graph down towards the x-axis. So right from here down to here, all of these ages are possible ages for which we can find accident rates for drivers. So in math notation, I can use inequalities, right? 16 is less than or equal to x, which is less than or equal to 74. Most mathematicians read this as x is between 16 and 74 inclusive. So this represents the age of drivers in the study. And the range is the same concept, only we're shadowing to the y-axis. So first, what does the range represent? It's possible accident rates according to this function. The actual range itself is represented along the y-axis from the top of the graph to the bottom of the graph, and that in this case is a list of numbers from 190 to 550. So I labeled my domain and range on the graph. I used mathematical notation to say what it means, or say what it is rather, and I also describe what the meaning of each of those number sets mean. The last thing I'll say about this is notice my notation. Here I use x representing the independent variable for the domain. Here I use f of x, which represents the dependent variable or the range. Possible values for the range. All right, I hope this was informative. For my classes, my instructions for you are to go back over the work that I assigned you to do, because I asked you to do this for homework that was due today. Now that you've seen my work, which will be posted on PowerSchool Learning, I'd like you to make the necessary adjustments on your work, and then there'll be a further information on PowerSchool Learning. So thanks for watching.